Today we are going to learn particle in a rigid box or infinite potential well. The application of Schrodinger's time independent wave equation. So let's write particle in a rigid box. So it quantum mechanically treat as particle enclosed or confined in infinite potential well. So for this we are going to consider a particle of mass m which will move by velocity v along x-axis between the rigid walls of x is equal to 0 and x is equal to L. So we basically consider particle trapped in one-dimensional potential well which has width L. So classical wave can be represented like this. So particle is trapped in rigid box. So it is a particle and restriction to the moment is only along x direction. So direction is only x. So x is equal to 0 to x is equal to L means box has a length L angstrom unit and it will be always n lambda by 2. So same can be treated or quantum mechanical treatment. It is illustrated like this. So motion of particle between two rigid walls is equivalent to particle trapped in infinite potential well. This particle is to be trapped in infinite potential well. So quantum mechanical wave. So infinity potential is applied at both x is equal to 0 and x is equal to L wall. So particle is to be treated as free within these two walls. X is 0 and x is L. So it's a synthetic concept. So consider as particle is a free, then potential applied on the particle must be 0. So V is equal to 0, while outside of a rigid box, infinite potential well or rigid box, potential applied is or potential offered is infinity. So outside is infinity, outside is infinity. Due to the rigid walls, infinity potential, particle cannot come outside by overcoming this potential. So particle should not be in region 1, in region 3. So particle should be only in region 2. So it is denoted by psi. Psi is the probability of finding particle. So probability of finding particle region 1 and 3 should be 0, while particle should be found in region 2. So psi is a wave function. Psi is a wave function associated with particle which moves within this box, and V is the potential. So as potential is always independent of time. So we must use Schrodinger's time independent wave equation and define the mathematical treatment. So as potential is zero where particle lies between 0 and L, means when particle is within box, and everywhere is except inside, that is outside everywhere, potential is infinity. So we are going to write simply otherwise. So psi is a wave function associated with the particle inside rigid box. It doesn't have an infinite amount of energy, potential energy, to come out the rigid wall. Hence psi should be zero everywhere outside the box. So potential is independent of time. So we are going to use Schrodinger's time independent wave equation. Schrodinger's time independent wave equation. So it also called as Schrodinger's steady state or simply steady state wave equation. So we write it del square psi plus twice m divided by h cross square e minus phi psi is equal to 0. This is in 3 dimension. So as we say, particle is within box and within box potential is 0. So we substitute it. Del square psi twice m divided by h cross square, remaining is only e psi, as potential is 0, particle is free particle is a free particle. Then we had restriction to the direction, means particle can vibrate in log x direction. So convert in 1 dimension, d2 psi by dx square plus twice m divided by h cross square e psi is equal to 0. This is 1 dimension along x direction only. So we are going to consider something constant about this as a k square d2 psi by dx square plus k square psi is equal to 0. This is 1 dimensional Schrodinger waves equation. 1 dimensional Schrodinger waves equation, and when you solve it, then we are going to get general solution for this Schrodinger's differential equation, and which will be again a function. And so general solution for this solution for the above equation can be written as psi of x, this is again a wave function, a sin kx plus b cos kx, a sin kx, where k is twice m, e divided by h cross square. So to find out the value of constant a and b, we have to apply boundary condition on psi by considering particle is within a box. So apply the first boundary condition. What is that? So psi should be absent. Psi should be absent means probability of finding particle should be 0 at x is equal to 0 1. So apply it on this equation. So psi should be 0 0, where at every value of x, then a sin kx is 0, so is a 0, plus b cos k x is 0 means cos 0. So this can be written as a sin 0 and cos 0 is a 1, so b. So a sin with 0 is a 0. Then from this we can get the value of b is a 0. So when we apply the boundary condition, first at x is equal to 0, psi should be 0. We get the general solution psi of x, a sin kx. Suppose equation number 1. So apply boundary condition second. So what is that? Particle is also not available, or probability of finding particle should be 0 at x is equal to L wall 2, second one. So apply this boundary condition on this. So psi should be, so this equation again, particle should not be on x is equal to L wall, is equal to a sin x is L. So write is at k x is L. So again we get a sin kl is 0. Its value of this terminology is again 0. But here we should think that a should not be 0, as a is a constant. So a is 0 means psi is 0 everywhere, means for all value of x psi is 0. It means particle is not within the box. So sin kl should be 0. So sin is a simple operation, so it gives the value according to the assigned value of theta kl. So kl must have something value which gives a sin 0. So everyone knows sin along with m or n phi always gives a 0 value. So we get sin kl is equal to 0 means kl must have something value n phi. So as n can be written as 1 2 3 dash 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 up to n values. Then again n should not be 0. As n is 0, then what we get? Probability of finding particle is always 0, means for every value of x, for every value of x, psi should be 0, which is not possible. So k is equal to n pi divided by L, and we should remember we have taken the value of k as something. So k is, we had considered k square is twice m e divided by h cross square. Then equate these two values. So as k square is n square pi square divided by L square is twice m e divided by h cross square, and find out the value of En. So En is eigenenergy value, n is a quantum number, and it gives, or it has value n is equal to 1 2 3 up to the n. So it can be written as n square pi square h cross square so this is n is quantum number divided by twice ml square. So we know h cross can be written as in Planck's constant. So as h cross can be written as h divided by 2 pi. So we can substitute the value for calculation. So h can be written as 2 pi h cross. So when you substitute this value, then we get the nth energy value for any particle, or En can be also known as quantized energy of any particle in any energy level. So it can be written as n square h square, Planck's constant, divided by 8 ml square, where n is again principal quantum number which has value, assigned values 1 2 3 up to the dash nth. So this is quantized energy equation. Sometimes say as a quantized energy or nth energy level for any particle. From this equation, it is clear that particle inside an infinite deep potential well, then it has only discrete values. It has only discrete values excluding 0, and these values are known as energy eigenvalues of nth particle. By taking this formula, we can say that energy level of an electron in 1 angstrom unit length box can be drawn like this, or n is equal to 1 means principal quantum number 1. We can find the values of this energy level, and supposed to be is V1. E1 energy level is 38 electron volt, when you find n is equal to 2, then it can be written as E2 is 152 electron volt and so on. So this is energy eigenvalue, and when you say the energy eigenvalue, this is simply derived from the Schrodinger's time independent wave equation, that particle trapped in infinite potential well or particle confined in a rigid box. So next we find the wave function. So eigenvalue we had seen, then we see what should be the eigenfunction associated with particle when it is trapped in rigid box. So wave function of particle in rigid box, in a rigid box, when particle is in rigid box. So we have derived when we apply the first boundary condition. This is the wave function associated with particle which is inside a box, and it is psi x a sin kx. As we know, value of k, a sin k is n pi, x is as it is L, and to find out the wave function, simply we have to do all this. Means well behaved wave function satisfy the normalization condition. Apply it, means integrate it, square it, integrate it over some volume and get the probability. So square it means psi of x square, integrate it, square it, integrate it over some volume. X is 0 to x is L, and the probability of finding particle should be 1. So this is LHS and this is RHS. So LHS, substitute LHS. So you can substitute the values from x is 0 to x is equal to L. Sine of x is a square, sine square n pi x divided by L dx. So take out a outside, a square as it is 0 to L, sine square theta we can write as 1 minus cos 2 theta divided by 2. So we take this analogy here, this formula, instead of theta, our theta is n pi x upon L. So 1 minus cos 2 n pi x upon L dx. So separate out, divide by 2. So everything divide by 2. So supposed to be I want to write here outside divide by 2. So a square divided by 2. Then integration is simply of 0 to L 1 dx and Another is 0 to L cos n pi x upon L dx can be written as a square divided by 2 is simply x 0 to L minus, this is integration of cos is simply sine, this is not theta, so with respect to x, L to n pi into sine 2 pi nx upon L. This is from 0 to L. But don't forget, sine with pi along with m or n pi, it gives value 0. Means either you put x is L, but it along with value of theta is along with n pi, so sine of n pi 0, and when sine 0 it also 0, so this value completely become vanished 0. Then remaining is only a square divided by 2, and this is L only, x is 0, so L, so your LHS value become a square by 2L and equate to the RHS value, which is 1. So a square divided by 2L is 1. So this gives value of normalization constant. Value of normalization constant E, and it can be written as 2 divided by L. So this gives normalization constant value A, which we had derived in square root 2 divided by L. Therefore, normalized wave function can be written as simply normalized wave function sin square root 2 by L sin 2 pi nx divided by L. So as you get the normalized wave function, so these normalized wave function are called eigenfunction. This is called eigenfunction. So we can plot the probability, and probability can be written as mod sin square or sin psi star. If complex wave function, then psi star. So it's a simply 2 by L sin square 2 pi nx divided by L. This is n, simply kx. K is n pi L upon x. So as is a sin is a sin kx. So this is the value of kx. Kx, when we plot the wave function for value of n 1 2 3, n 1 2 3, so probability and their wave functions can be look like this. So particle is within box, so x is 0, x is L1. So it's psi 1. This is a wave function. So first wave function can be look like this. So if we draw psi 2, means principal quantum number value is 2. So it can be look like this. And it's like as third supposed to be here, then it will be like this. This is a wave function, and as you derive plot the probability value, probability density in rigid box. Again, rigid box. So probability for n is equal to 1 means psi 1 of x. So this probability value is again a Gaussian value. Probability is always Gaussian. For psi 2, psi may be positive, psi may be negative, psi may be complex. Probability is always real and positive. So similarly for psi 3, so it's simply like this. This particle, from this diagram we know particle having lowest energy in E1 has a wave function psi 1 for which the probability of finding particle is maximum at the center of a box and becomes 0 at x is 0 and x is L1. So while for a particle of energy 2, n is equal to 2, probability of finding particle is 0 at the center. 0 at the center. We predict that quantum predicts certain forbidden region for a particle for certain energy, and this cannot be predicted by classical mechanics, in which there is the same probability of finding particle throughout the region. So this is the wave function associated with particle when trapped in infinite rigid box. So let us, we are going to take one problem, this quantized energy equation formula. Supposed to be problem is like this: calculate first two energy eigenvalues of electron in electron volt which is confined in a box of length, this is value of L, box of length 2 angstrom unit. So I have to find first two energy eigenvalues. So given data is given or data, so L, this box of length is 2 angstrom unit, 2 into 10 raised to minus 10 meter. Then mass of electron we know 9.1 10 raised to minus 31, and these values we will substitute The required formula to get the eigenvalues. Eigenvalues, quantized energy equation or nth energy value can be derived from simply formula En is equal to n square h square divided by 8ml square. Substitute these values. Remain n as it is. Planck's constant 6.63 10 to the power 34 bracket square. 8 mass of electron 9.1 10 raised to minus 31, and box length is given 2 angstrom unit. Square it. So when you do this calculation, it's a simply 1.5 into 10 raised to minus 18, n square is as it is. This value comes in joule. En. Convert in electron volt. So 1 electron volt, 1.6 minus 19 joule, it gives you joule. So divide this 10 raised to minus 18 n square by 1.6 10 to the power minus 19 joule become electron volt. Joule become electron volt. En is equal to, so is 9.43. So this values little bit vary as per your calculator digit setting. Electron volt. And then we derive first two energy eigenvalues. So substitute for first two values. First, n is equal to 1. Then this equation become E1 9.43 into 1 square electron volt, simply 9.43 electron volt for N1. Second case, for 2, E2 9.43 principal quantum number second